question is what is said. The frequency is given f is equal to 50 hertz and the RMS voltage that is equal to 30 volt. Represent the waveform. According to that, he asked the sinusoidal voltage. Okay, 30 volt is the RMS voltage. We know that RMS voltage is Vm divided by root 2. According to Vrms, we find here Vm is equal to root 2 into Vrms, that is equal to 1.414 is equal to root 2 value. When we multiply it with Vrms, we find into the Vm. Vm is equal to 42.42. Okay, now omega is equal to 2 pi f, and according to that we put into sine terms and find the result, that is our answer. Okay, next question is maximum current in a series RLC network with variable frequency excitation is 1 ampere. When the applied voltage is 10 volt, the inductance has a value 0.1 Henry. The Q factor is 10. Then value of capacitance is here. First of all, what is that? Okay, maximum current flow when the resistance or the impedance in the circuit is lowest, means V is equal to IR. This is a constant we assume. If I value is increase, then R value decrease if V is constant in that case. If R value increase, then I value decrease if V is constant. To maintain this equation, if I is increase, R should be decrease. That should be applied here. According to that, means that the maximum value of current is coming in this in RLC circuit only when that is work on the resonance frequency. On resonance frequency, the impedance is lowest, and that impedance present in the circuit that is purely resistive, and L or C components, these are cancel out to each other, and according to that R is equal to 10 ohm, and 10 ohm we know that quality factor in the RLC circuit is Q is equal to 1 by a root LC. Here put the value of R and L as find out the C value. According to the formula, C value is equal to 10 microfarad. Okay, next question is the gain of a bipolar transistor drop at high frequency. The gain of a bipolar transistor drop at high frequency due to reason of internal capacitance of a transistor, means inter-electrode transistor capacitance. That option is C is the basic answer of this question. At low frequency, coupling and bypass capacitor doing work, but high frequency junction capacitance, also called the internal capacitance of the transistor. Okay, next is what he said. Current in a coil of self inductance of 4 Henry change from 10 to 2 ampere in t second, and the induced EMF is equal to 40 volt. That time period, means time is to find out time, that is he said we know that V is equal to L di by dt. According to that, di means change in time from 10 to 2, means total change is 8 ampere. So according to that, 4 into 8 ampere with respect to time, that is equal to 40, means we find out t, we find out t is equal to 0.8 second is our answer. Okay, this is also an important question. Pose product of some express. First thing, if sum of product term is used, then we use NAND gate, because number of gates required to implement the digital circuit is lowest. In POS form, we use NOR gate, NOR circuits. That is our answer. Okay, this question is asked from the microprocessor, and he asked using some commands, instructions given, and said to find out the value of accumulator at the result. What he said, if firstly what initially carry flag is reset condition, means carry flag is 0, carry is 0. Okay, first instruction is that accumulator is move immediate data 04 into accumulator is loaded with 04 means 000. This is the data which is in accumulator at present after this instruction. Then he said the rotate right, accumulator को right rotate करना है या right shift करना है. According to that right is in the direction this move and the result comes this. After that he said A data is moved to B, we save A data into B and then apply rotate left because in A we know that this is the A data at present. We apply left instruction 1 2, this one come here, this one come here. Okay, 0 0 0 0 0. This is A's data at present after this instruction. Then this data is add to B. B has 0, this content, and after that at result we get 1 0 1 0 0 0 0 0. And then again apply right shift operation. According to that this shift here, this here, and we get 0 0 0 0 0 1 0 1, that is 0 5. That is our answer. This is the last another question which is numerically asked in the examination. What is said, he given the HIE. These are in firstly I think want to tell you, this is the H parameter coefficient in the common emitter configuration. Here HI is 1 kilo ohm, HF is 30, HRE approximately equal to 0, H naught E is equal to 20 into 10 to the power minus 6 mho. RL is given the load, and this is the single stage common emitter amplifier. The voltage gain and power gain. Firstly, voltage gain is equal to AV is equal to AI into R naught, means output impedance divided by input impedance. That is our voltage gain, because AI is equal to output current divided by input current. According to that we multiply the output impedance with the output current and input impedance with the input current, and we find out the output divided by V input, that is our voltage gain. Here we apply this and we find the R V naught divided by V is equal to 75, and we know that power gain is equal to AP. Power gain is equal to AI into AV. We find the value of AV. AI is equal to HFE divided by 1 plus HOERE. HOERE approximately 0.05. After calculation we get plus 1. That is approximately 1. So that AI approximately is equal to HFE. So 30 is multiplied with 30 is multiplied with H75, that is 75 is AV, and AI this is we find out that 2250. That is our answer is 75 and 2250. Okay friends, we come into next part some other subjects questions. So my request is that please like, share and subscribe my channel. Thank you.